Like a lot of applications, we often include some form of tracking and social scripts like this that help us understand how people use the application or allow us to embed some sort of, for example, live chat widget for support purposes. And here you can see I have a little tracker library that has an identify and a track call. And we would typically include this inside of our Angular application using a script tag with some sort of async attribute, or find some other way to load this outside of the primary page flow so as not for it to become a blocking point of failure. But what I'm seeing increasingly is that the browsers and the browser extensions are blocking certain types of scripts, which means that at runtime, this library is no longer available, which forces us to have to write this sort of awkward looking code that looks for this or falls back to something like using an array and then pushing events onto that array that then would get drained when the library loads. And I'm just increasingly becoming dissatisfied with that approach. And what I'd like to start doing is encapsulating these third-party scripts inside of an Angular service such that the rest of the application becomes completely unaware of the underlying library. And this has a few advantages. One advantage is that the consuming code doesn't have to worry about whether or not that library exists because the Angular service is always part of the compiled application code. So for example, I can inject this third-party tracker here and I can just call identify here and I can call track. And I never have to worry about whether or not this tracker.js file was actually loaded or blocked by an ad block or failed to load over an HTTP request. The rest of my application code just works as it expects to work. Now, not only does that keep the consuming code pretty simple, but it also provides us with an opportunity to create a detailed documentation around what that library is actually supposed to do, right? Rather than trying to pick apart a minified third-party library or look through docs, which are often out of sync with what's actually being delivered to the application, something like our third-party tracker now gives us a clean API that we can actually look at as a developer to understand what that library is doing and what's expected of us, because especially in the TypeScript context, everything gets typed out so nicely. So before we dive into this code, let's just take a look at what's happening in our web application. So if I refresh here, you can see that I'm identifying the user. Now this info line is coming from my Angular service and the warning line is coming from the underlying tracker.js file, and you can see I've identified the user, and if I do this and then do that, you can see that we're tracking the actions, again, both in our Angular service as well as the underlying library. Now, this is the happy path, which is not super interesting. Where it becomes interesting is when we dive into the network, and let's go ahead and have our Chrome DevTools block, no, not the request domain, block this library. So now when we reload, you can see, you can see that the tracker.js file has been blocked by the DevTools, and our Angular application continues to work. Nothing in the Angular code had to become cognizant of the fact that that tracker.js library was no longer available. You can see I'm continuing to identify, I'm continuing to track. The only thing that we're seeing is that this is the Angular service and we're not getting that underlying warn console logging from the tracker.js file because the tracker.js file doesn't exist. So let's take a quick look now at what's going on under the hood. So first, I'm going to just augment the global namespace, telling it that there's going to be this thing called tracker with this tracker interface, and that's so that TypeScript doesn't complain. A lot of times something like this will be automatically made available through your node modules if you've npm installed a library, or you can probably grab a library from definitely typed. But sometimes I think it's nice to just come here and explicitly identify the parts of the API that your application is going to consume, again, to provide this well-documented library that you can then use within your Angular application. So here we have our tracker interface. It has that identify and track call. The identify takes this user identity. The track takes some other methods, some other properties here. Again, just creating a nicely documented thing, again, that we can also use as our type annotations in our wrapper library. So our third-party tracker is going to expose the identify and track methods, and it's going to turn around, get the tracker library. That's going to return a promise which resolves to our tracker, and then you can see we're actually calling the methods on the underlying library. Well, what happens though when our the loading of the tracker.js file is blocked by an ad blocker or by network disruption? How do we continue to work, especially when we're just resolving here with the library and then calling the underlying library? Well, that's another thing that's nice, I think, about wrapping the third-party logic, is that we can more cleanly handle failure cases. So this get tracker call returns a promise that resolves with something that implements the tracker interface. And what we'll see when we look at the get tracker call is that it's going to look for things on the global namespace, right? It's going to look for the actual underlying library. And if it's not available yet, it checks to see if the document has loaded. If the document hasn't loaded, then we're going to bind to the window.load event to wait for all of the third-party scripts to load. And eventually, what it's going to do is either resolve with the window tracker, right, and the window load, or if it was available here, or it's going to resolve with this no-op tracker. And the no-op tracker, in this case, if we scroll down, implements the tracker interface that we defined above, but is essentially a no-op or no-operation implementation. So we can essentially consume this instance as if it were the global tracker.js library, but calling identify, calling track, just discard the data. So from a business intelligence standpoint, this no-op implementation provides zero value. But from a consumption standpoint within the rest of our Angular application, everything becomes much cleaner because the get tracker never has to worry about whether this tracker value is null. The application code, because we're using the third-party tracker encapsulation, never has to worry about whether there's an underlying library or even that that underlying library even exists. And I think this pattern just creates much more cleanable, much more clean, much more readable, much more maintainable code, because we're creating well-documented services, services that we know will always exist because they're Angular services and we know they get compiled into the runtime. And we completely hide the fact that there's even this underlying library which is increasingly becoming a point of failure in browsers that have either native ad blocking or browser extensions that block libraries that track or add or do any kind of thing that might be considered suspicious depending on how you squint. So I'm just increasingly thinking that this is a really attractive pattern that I'm going to be trying to use more and more going forward.